Alright, hey AP Chemistry. So I wanted to make a quick video on how we could write and identify conjugate acids and bases. In general, a conjugate acid requires the addition of H+, which if you remember H+, that's my proton, or sometimes we call it the hydronium ion from H3O+, okay? But in general, we're adding H+, okay? And then a conjugate base is the opposite of this. A conjugate base is the removal of H+, okay? And then a note here is that when I add H+ to my conjugate base, I'm adding a +1 charge, okay? When I'm removing an H+, I'm subtracting a +1 charge. Typically it's gonna give me my -1, or I'm gonna subtract 1, right? So I'll subtract 1 from the charge, okay? So if I were to do HA, if I were to do the conjugate acid of HA, right, so I'm going to do that first. Let's say I want to do the conjugate acid. Let's say that was the thing for this. I'm going to add H+ to HA here. So if I want to add H+, I'm just going to add another H, right? So it's going to be H2A, and I'm adding a +1 charge. So it's going to be H2A1+, right? So this isn't typical, but this is what I mean by adding an H+, right? I added an H to HA and I get H2A. If I want to make the conjugate base, which is something that we're used to seeing, I'm going to remove H+. So I'm going to remove that H, and I'm left with A. I'm also removing a +1 charge. Now remember from way back in ionic compounds, this is H and this is A. H is a group 1 element. It typically forms a +1 charge, which means to make this compound, A must be a -1 charge. Together, +1 and -1 make this a neutral compound. This is way back to like chapter 3 and 4 when we're doing ionic and covalent bonding. Remember, hydrogen typically forms +1 charge, and so if I want to have it in a compound, the sum of the charges typically need to equal 0. So that's where if I'm removing +1, if I remove this, I'm going to be left with A-, or A-1. That's going to be my conjugate base. Now, I'm going to do this for a bunch of them. So let's say, instead of having HA, let's just do something like if I had, let's say I had H2S, okay? If I want to write the conjugate acid of H2S, if this was something that was real, if I'm protonating or giving H2S a proton, I add H, it would be H3S +1 charge. Okay, now that's not typical, but it could be, this is a conjugate acid, I'm adding H+1 to this. For conjugate base, I'm going to remove an H+, and I'm going to subtract +1. Now this is neutral. If I subtract +1, I'm going to be left with -1. So the conjugate base would be HS-1. So this is another example of conjugate acids and bases. Let's do another one. Let's say instead of starting with H2S, I start with HS-1. Okay? Now, going back to ionic charges, remember, hydrogen is always going to be for us +1 charged. This sulfur, if I typically know the charge of sulfur, sulfur typically forms -2 charge, and we have to remember the sum of the charges must equal the overall charge. These are just some from old notes, okay? So the sum of all the charges must equal the overall charge. For a neutral compound where I don't show you a charge, that means it must add up to 0. For a charge like this, for like a polyatomic ion, it must add up to whatever the ion charge is. So for this example, it adds up to -1. Okay, so what must sulfur be that when I add it to +1, I get -1? Mathematically, that means that this sulfur must carry a -2 charge. So keeping that in mind, hydrogen's +1, sulfur's -2. If I put the two of them together, I get my -1. All right, if I want to make the conjugate acid of these two, I'm adding H+. So if I add H+ to this, I get H2S. If I want to make my conjugate base, I'm going to subtract H+1. If I subtract my H+1, I'm going to be left with my sulfur that's a 2- charge. Okay, this one's a little bit tougher to see, but if I remove another proton, I'm just left with sulfur as a 2- charge. Let me do another example. Okay, let's say I'm going to do hydroxide, HO-. Side note, hydrogen is always +1 charge. Oxygen typically forms by itself a -2 charge, so keep that in mind. This is ionic rules, but you can still do it using this acid-base conjugate business. So if I want to make my conjugate acid of HO-, I'm going to add H+. If I add an H+ to OH-, I get H2O. If I want to make the conjugate base of OH-, I want to subtract H+, and I'm going to be left with O2-. Okay? So that was a bunch of examples about making conjugate acids and bases. Let's see about identifying them in chemical reactions, okay, and acid-base reactions. So let's do something like if I had HCl plus OH-. Okay, and now I know this is a strong acid, OH- is a strong base, right? If I make this, I'll get H2O plus Cl-. All right, so now my job is to identify conjugate acid-base pairs. Right, I'm going to call them conjugate acid-base pairs. Conjugate acid-base pair. I'm going to call that one conjugate acid-base pair. I'm going to call that 2. There are always going to be 2 in these type of reactions. So let me identify something that I know in the beginning. I know that HCl is an acid. How do I know it's an acid? Not only is it on my strong acid list, it has the structure HA. HA is the structure for acids. So for my first conjugate acid-base pair, one of my acids is HCl. This is my acid. If I want to identify or locate or figure out the conjugate base, I need an acid-base pair. This will be my conjugate base. I'm going to call it my conjugate base. If this is my acid, I could make the conjugate base. This is just, I call it an acid because that's what I started with. How do I make the conjugate base of HCl? Well, we just did a bunch of examples, but I remove H+. My conjugate base for HCl should be Cl-. And so I'll put a box around here, and I'll put this and say this is my conjugate base. And this is my first conjugate acid-base pair. It has my HCl and then my Cl-, or my HA and my A-. I've removed a proton from here. Both of them have Cl in them, but their difference is a proton or H+. That's how I'll know what's a conjugate acid-base pair. It has one less or one more H+ in it. So let's do a different one in a different color. The only other two left are OH minus and H2O. I know that OH minus is a base. How do I know that? I mean, OH minus is hydroxide, which is by definition defined as a base. So I have OH minus, that's my base, right? So I'll start writing my acid-base pair here. I'm going to put base, which is OH minus. If I know this is my base, what would my conjugate acid look like? Well, conjugate acid adds H+. If I add H+ to OH minus, I'll get HOH, which is the same thing as H2O. I added H+ to OH minus, plus and minus will cancel out, and I'll get H2O. Here is my conjugate acid, and notice how I did it in a different color. These two are a conjugate acid-base pair. There are two conjugate acid-base pairs, right? This is my acid, my HCl. If it's an acid, the only thing it could do for right now is be a conjugate base. So I got my conjugate base, which is Cl minus. For my OH minus, the only thing it could do right now is become a conjugate acid, which is my H2O. Let's do another example. All right, so I'm going to erase everything, but keep the labels basically the same. Okay? It typically will follow the structure of conjugate acid, conjugate base, acid, and base, right? So notice on this side, I labeled it as acid base, and this is conjugate acid and conjugate base. Now, a chemical equation would give it to you that way, or you could write it that way. Let's do something else. Let's say I have HC2H3O2, okay? And I have, I will say, NH3. These are both weak acids and bases. How do I know? This has an H in front of it, and this is a weak acid. How do I know? It's not on my list, or I'm telling you. So this is a weak acid. And NH3 is a weak base. So NH3, we should be familiar with it. It's our new best friend. NH3 is ammonia, and that's a weak base. Now remember, by definition, bases take H+, and acids give H+. So what's going to happen is, this NH3 is going to get an H+. And so I'm going to write it as a conjugate acid over here, and this is how it's going to be written straight through. It's going to be NH4 plus 1. This is my base, and this is my conjugate acid, so I'm writing this a little bit differently. And then if this is my acid, my HC2H3O2, if I want to write this as my conjugate base, I'm removing that H. And I'm going to get C2H3O2 minus. And I've already color-coded them and put them in the boxes. If HC2H3O2 is my acid, the conjugate base is going to be C2H3O2 minus. If my base is NH3, which I've labeled it, I should know that it's ammonia. If my base is NH3, my conjugate acid must have one more H+, if you remember. I added an H+, right? You add an H+ to conjugate acids here, and I get NH4+. Okay? So, I'm hoping this video was helpful with identifying what's the conjugate acid and base, like what do I do, how do I make conjugate acids and bases, and where they show up in chemical equations. Typically on the AP exam or even on your quiz, it's going to be a multiple choice question that's just like, which of the following correctly identifies acid-base conjugate pairs? So you'll have to do something like this. Okay? Now, the thing to be careful for is not to say that HC2H3O2 is your acid and that NH3 is your conjugate base. No, 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 no. These two do not have similar elements or similar compounds. And these two do not differ by one proton. By definition, your conjugate acid or base differ by that one H+. Either it has one more or it has one less. So, make sure that you don't confuse these two as conjugate acids and bases. A conjugate acid-base pair must have only an H+ as their difference. Alright, so hopefully this video was helpful and we could be a bit more successful with acid-base conjugates.